Now we'll try to have a quick overview of translation of input through the various compilation phase. To start with, we'll take a small programming statement which has three variables. Position is equal to initial plus rate into 60, where position, initial, and rate are considered as variables. This programming stack, a high level programming code segment, is passed on as input to the lexical analyzer. To recollect, lexical analyzer is scanner which scans through the program and tries to identify patterns such as try to identify tokens such as identifiers, operators, numbers, so on and so forth, based on the pattern which is represented using the help of regular expression. And lexical analyzer tries to generate a stream of tokens, which is the token category, as well as the lexeme, which is the instance of a token. This token will be passed on as input to the further phase. And now, the next phase, the output of lexical analyzer is identifier, and one is a pointer to the information of the variable position in the symbol table. So during lexical analysis, symbol table is also generated uh, parallelly. Whenever it finds an identifier, it either stores it or adds up the information pertaining to that identifier in the symbol table. So symbol table is a data structure which gives you the information about the variable as well as its details. Now, this stream of tokens are passed on as input to the syntax analyzer. Syntax analyzer or parser tries to check whether the syntax of your program is correct based on the rules which is prescribed by the programming language. How do we do it? We prescribe those rules in terms of context free grammar, and we have parsing algorithms to reconstruct the program to identify if there is any mismatch based on the rules which are provided. And therefore it is every of the identifier or the number is considered as leaf nodes, and the operators comes as the intermediate nodes. Now, the output of the syntax analyzer is passed on as input to the semantic analyzer. The job of the semantic analyzer is to check whether there is any data type mismatch. Now, in this example which we have taken, uh, identifiers are considered as float, where 60 is an integer, and therefore an implicit conversion takes place here. One second. An implicit conversion takes place here, where 60 is converted to float and then the rest is being as such. If there is no data types mismatch, the output of syntax analyzer and semantic analyzer would be the same. But here, since there is a mismatch, an implicit conversion takes place. Now, when I construct a syntax tree, it's mandatory that you take care of the priority or the precedence of the operators. Since in this example, star has the highest priority, we evaluate id and star rate and 60 first, and then that is added with the value which is prescribed by initial, and then it is assigned back. So priority of the operators is mandatory when you construct an syntax tree. And then comes the intermediate code. Intermediate code, onto the right hand side of equal to, maximum of one operation can take place, and therefore a conversion of into float is considered, which is assigned to t1. What is t1, t2, t3? T1, t2, t3 are temporary variables which are taken from the pool, which is pool of variables which is provided by the compiler. It helps you to store the intermediate stressor. So the large statements are broken down into simpler statements. We have three address code, quadruples, triples, syntax tree itself, postfix notation. All these are part of intermediate code generation. Here, as such, we talk about a similar representation where to the right hand side of equal to, it is maximum of one operation or none. So first, in the first statement, you convert into float. Second, you add the intermediate result, which holds in the converted value of 60, and multiplies it with ID3, and then you take the value, add it with the ID2. Then the last one is just a copy statement. So this is how you translate it. And then comes the code optimization phase. Code optimization phase can be is optional and can be applied after intermediate code generation or during the code generation process itself, where you try to convert it into a target language. So now you have code optimizer where a conversion takes place and you multiply. Now, in this example, 60 is a constant, and therefore, code optimizer takes it at 60.0, reducing the cost of conversion, and directly multiplies it with ID3, combining T1 and T2 as a single statement. And then what happens in this third and fourth statement? It tries to add and assign. The third statement, there is an addition operation. Fourth statement is just a copy statement. And so those two are combined. Now, by combining 1 and 2 and 3 and 4, you have reduced the number of operations, reduced the use of temporary variables, and reduced the cost, certain cost of duplicate operations. These can be identified by certain optimization techniques, which we'll be taking up in module 5. But as of now, it has been reduced. So the code optimizer has given us two statements, which in the last statement will be converted to the three-headers code, the target machine code, where your ID3 is taken, stored onto register 2, and then 60 is added with the register 2 content stored onto register 2. ID2 is taken, which is stored onto register 1. Since you have register 2 content and 1 which is added, we are adding it and then storing it back to ID1. So when you are asked, this is how the overall translation happens. When you are asked to translate any given programming structure, uh, we expect the programming structure to be divided into various phases. Any, if you have any doubts, you can WhatsApp.